Okay, so there are 3 energy-bearing nutrients. So we've got carbohydrates, proteins, and lipids, right? Now, what do you need to know? So in terms of carbohydrates, we've got 2. So 2 sources of carbohydrates. The most important, of course, is starch, which is the plant one, right? And then glycogen is not a significant source of carbohydrates for humans, but it is found in animal tissues. Okay, so they are digested to monosaccharides, and monosaccharides are absorbed, and monosaccharides are absorbed in the intestine. Then you have proteins, which so you have animal proteins that are complete, and you have plant proteins that are incomplete. What does that mean? So animal proteins contain all essential amino acids, all 21 amino acids that humans need for proper growth. Plant proteins do not, but you can combine vegetables and legumes like beans, and that will result in complete plant protein. Does that make sense? So basically, if you decide to go vegetarian, it's a bit of a pain in the ass, in terms of dietary formation. Does that make sense? And then our favorite ones, of course, fats, triglycerides. So we have 2 main groups of triglycerides. Saturated fats, which come from animals, and they are solid at the room temperature. Does that make sense? These are solid. Clear? Like butter or lard. And then we have unsaturated fats, which come from plants. So this is what we call oils, and they are liquid at the room temperature. Okay, so I'm going to spend a little bit of the time talking about sort of nutritional values of different products. So how much calories do you want to get from each nutrient? Depends on what kind of diet you want to use. If you, for instance, want to use a low carb diet, then carbohydrates should comprise not more than 50 to 150 grams per day. Now, fat and cardiovascular disease. What I want you to understand is that current studies do not support any correlation. There's no correlation between the consumption of saturated fats, and that's important, in the diet, and increased risk for cardiovascular disease. Does that make sense? Yeah, I know, but there are multiple studies showing that no. Again, when I say consumption of saturated fats, I don't say that you start eating 5 sticks of butter a day, I mean, if you are a meat lover and you eat eat dairy products and I don't know, pork and beef and eggs, it's all fine. Does that make sense? Now, what is associated with increased risk of cardiovascular disease? So oils are definitely cheaper than saturated fats. Does that make sense? This is why at some point if you hydrogenate oils, so you take plant triglycerides and do a certain chemical reaction, they become trans fats. For instance, margarine. Does that make sense? In these guys, they do significantly increase the risk for cardiovascular disease. I mean, in the diet. This is why, to my knowledge, trans fats are banned in Europe, and more companies stop using trans fats in the United States. Does that make sense? Are we clear?
You said that
Hmm?
they're cheaper than
Just say again?
that unsaturated fats are cheaper than saturated fats.
Oils are cheaper. Any plant product is simply cheaper than, like, if you take 1 pound of sunflower oil versus 1 pound of, well, pork fat, sunflower oil will be cheaper. Just because, it's easier to grow. So at the end of the day, instead of using butter, which is really expensive, right? People started making vegetable shortening, which was a great cheap replacement of butter, but turns out that it massively increases the risk for cardiovascular disease. Does that make sense? Now, while we are at it, I want to, because I know the order of material as I explained it there, I wanted to jump really quickly to the fat transport, and since we're talking about diet, talk a little bit about cholesterol, okay? Because it's technically fat too. So when we eat something, fat like lipids, all lipids get processed in the liver. Does that make sense? Now, fat per se, like triglycerides, they cannot be transported via blood because they are hydrophobic. Does that make sense? So when liver has to, quote unquote, ship fats to different parts of the body, it packages them. So here's going to be liver, okay, and here it's going to be tissues. Does that make sense? Are you following me? So liver packages fats into what's called VLDL and LDL. Okay, so LDL stands for low density lipoproteins. Okay, does that make sense? Now let me ask you this. If you will throw a piece of fat or a drop of oil in the water, will it sink or will it float? Float. Floats because fats have lower density. So low density lipoproteins, or check this out, V stands for very, very low density lipoproteins. A lot of fat and cholesterol. They contain a lot of fat and cholesterol and very little protein. Basically, protein is just sufficient to make them hydrophilic. Does that make sense? So this is why they are low density, because of really large lipid content. Does that make sense? Now, when tissues recover all the lipids that they need or they can, whatever is not used is sent back to the liver in the form of HDL. And HDL stands for high density lipoproteins. And in this case, the protein content is much higher, or if you want to think of it this way, not a lot of fat and more protein. Does that make sense? We're good? Now, important question, why are we talking about this? When you go to a physician and you know how they say, oh, we measure your cholesterol. Well, turns out that there is absolutely no correlation between dietary cholesterol and blood cholesterol. Make sense? So if you eat like 3 eggs a day, which contain a lot of cholesterol in the yolk, right? But it doesn't affect your blood cholesterol because 85% of your cholesterol are made in the liver. Does that make sense to you? Most cholesterol that circulates through your blood is produced in your body. So last 15% that you get from food, you really have to double down on those eggs. Like we're talking about maybe 2 dozen eggs a day. We'll put a dent a little bit, we'll increase it. Does that make sense? Much higher role in cholesterol levels is played by trans fats. If you consume trans fats, that increases cholesterol dramatically. But what is more interesting, and that I want to put in writing just to give you an idea, and it's been established that total blood cholesterol does not correlate with cardiovascular disease. So when you hear statements, and yeah, that was a huge Framingham study that first showed this, that when you look at total levels of cholesterol in the blood, are you following me? There's no correlation between total levels and the risk for CVD. This is why now you are familiar with the terms LDL and HDL, because this is what matters. Turns out that low-density lipoproteins, they are positively associated with the risk of cardiovascular disease. The higher your LDL is, the higher your risk. Does that make sense? And the higher your HDL is, the lower your risk. So this is why I don't really know why when you go to the physician, they still measure total cholesterol, because it makes no clinical sense. What does make sense is your ratio between HDL and LDL. Does you understand? Like you want higher this and lower that. Good?
Does higher LDL correlate to higher trans fats in your diet?
The other way around, yeah. So if you consume a lot of trans fats, you're going to have massively increased LDL. Yes, that is correct. Yeah. Questions?
So when people have hyperlipidemia and they don't want to do medication, they just want to do lifestyle changes. It's not.
If it's genetic, yeah, good luck with that.
Yeah, so it's okay.
It's in some folks, hyperlipidemia is associated with the diet, but I have a very good friend who is skinny. He has inherited family hyperlipidemia as a gene deficiency or something. So he has to live on statins, which is separate story. Statins is an interesting beast in itself. Really interesting drug. Basically, let me put it, it's just very short quip. So what do statins do? they reduce levels of triglycerides in the blood. They reduce LDL basically. Does that make sense? And taking statins is associated with the reduced risk of cardiovascular disease. Now, if you follow this logic, then any other drug that would reduce LDL would also reduce the risk for cardiovascular disease. Well, not to the extent that statins do. So if you produce the drug that only controls for LDL levels, that reduces them by, let's say, 20%, no, it's not that much, no. It's not that reduction in cardiovascular disease as you would expect. So basically what I'm trying to tell you, statins do something else in addition to reducing levels of LDL in the blood. And what they do, we still have very little idea. They do help to prevent stroke and myocardial infarction and reduce atherosclerosis levels. Does that make sense? So the last bit that I want to talk about here is non-energy bearing nutrients. Okay? So what you need to know. So it's basically going to be vitamins and minerals. So we're going to start with vitamins. And I'm going to highlight which ones you need to know. So vitamins can be fat soluble. And this will include vitamin A. So what I'm going to do, look, I'm going to write a vitamin. And if you need to know what deficit leads to, I will write it next to it. Does that make sense? So deficit of vitamin A results in nyctalopia or night blindness. Deficit of vitamin D results in rickets or osteomalacia.
What does deficit mean?
Huh?
What does deficit mean?
Deficit? Not a lot. Not enough. Not enough. Not just not a lot, but not enough. Okay? Should be 2 T's, but or 1. No, I think it's still 1 T. Rickets. Then you have vitamin E, which doesn't have any particular sort of deficit stored in vitamin K, which is really vitamin K. Deficit of vitamin K results in coagulation problems. But on the bright side, it's almost impossible to become deficient in vitamin K because it is actively produced by intestinal bacteria. Okay, does that make sense? So these 4 are fat soluble. All other vitamins are water soluble. Am I clear? Now, which ones, sort of with pathologies, I want you to know. Deficit of vitamin B1 results in a condition, neurological condition known as beriberi. Okay, it's basically nerve degeneration, peripheral nerve degeneration. Deficit of vitamin C results in scurry. People losing hair, teeth, nails, really bad skin. That happened often to sailors on the long trips before the invention of vitamins, And the treatment for this was, as far as I remember, what they did, they figured out that they can use lemons as the massive source of vitamin C, but I think they had to salt them, which probably was just absolutely terrible in terms of taste. Vitamin B12 results in pernicious anemia. Now this is an interesting one. B12 is a vitamin that is needed for fast dividing cells, and red blood cells are pretty fast dividing. That makes sense? So no B12, you have very little red blood cells. Now, one important feature, one important difference says between fat-soluble and water-soluble vitamins is that in case of fat-soluble vitamins, you actually can get an overdose because they tend to accumulate in adipose tissue. Like people can die from an overdose of vitamin A. One of the famous stories was about the polar explorers, Arctic explorers, that the basically only source, if you think about it, the only source of meat in the Arctic is polar bear. Setting aside all the parasitic threats that can come from polar bear meat, some folks ate liver, and polar bear liver is incredibly rich in vitamin A, like insanely rich, and people died. Just like 2 people consume an entire liver and they die next day because of vitamin A poisoning. On the opposite end, water-soluble vitamins, it is really hard to get overdose. So you can get an acute overdose if you go and pop, I don't know, 300 pills of vitamin B12. Yeah, sure. But that actually plays into one of the greatest scams ever, vitamin industry. The vitamins that are sold in a grocery store or pharmacy or wherever, there are absolutely no studies showing any benefit for an average person on an average balanced diet from taking vitamins. I know it comes maybe as a surprise, but I'm not talking about, let's say we talk about pregnant women. Yes, they have to take nicotinic acid and folic acid. Those are essential vitamins for a growing fetus. Sure, they have increased demands in a certain water-soluble vitamin. Does that make sense? Or a child, like here in Ohio, you know how much sun, I think I mentioned that, how much sun we should get every day to get sufficient vitamin D. 15 minutes out in the sun stark naked. It's not going to happen. So it's recommended for people who live in areas like Cleveland to take vitamin D, sure. But if you look at those vitamin C supplements, for instance, that's my favorite. Like Emergency, something like that. It's 1,000 milligrams of vitamin C, as far as I remember, per pill. Well, your daily norm is 300, and everything above that, you will just pee it out. Okay, a friend of mine actually did an unhumane experiment, and I think he took 30 daily doses of vitamin C at once when he was in high school. All that happened, his pee became very, very orange. That was it. No side effects, nothing, like he didn't gain any superpowers. And on top of that, if you wonder if vitamin C limits your cold, no, it doesn't. There were multiple studies showing that taking vitamin C when you have a cold, a flu, no, it doesn't help. So, if it feels good for you, sure, go for it, but it doesn't have to be.
What about, you know how people eat the placenta?
Oh, that's yeah, I know women. No, that's not useful. No, that's no. We can talk about it in a second. Let me finish with the minerals, and I'll tell you a fun story about this placenta story. So minerals. So what do you need to know here? There's a bunch of macroelements and microelements. So macroelements are ions like sodium, potassium, chloride, calcium. Yeah, I think that's it. I'm not counting sulfates and others. So what do you need them for? Well, obviously sodium, potassium, chloride you need for maintaining sort of ionic strength, ionic balance in the extracellular fluid, for electrical conductivity, blah blah blah, water retention, all that kind of stuff. Calcium, bones, obviously. Does that make sense? Now, microelements. The ones that I want you to know are very limited. It's going to be iron, iodine, fluorine. So iron, only if you running low on it, then it makes sense to take iron supplements. So iron is blood, okay? Iodine, thyroid function. Fluorine, usually water is fluorinated, teeth. Does that make sense? We good? Other than that, I don't really know what to tell you here.